All right, today we are doing distance problems. So when we are doing distance problems, there's three different kinds of scenarios that could come up. This may be kind of hard because there's going to be some times where I'm going to do some live diagramming. But the thing to remember about these kinds of problems, these are probably the most difficult because half of what you have to do is implied and it's not said to you. We don't talk about it. There's items that are implied, like when you say the word perimeter, it implies you should use a formula. P equals 2L plus 2W, perimeter of a rectangle. Okay, the same thing is happening here. So when we are solving distance problems, there are different kinds of scenarios that take place. The first one is when two people are leaving at the same place. Person A is leaving from the same place that person B is leaving from. One is traveling faster, one is traveling slower. Maybe they leave at different times. But if they're leaving and they're going to the same place, there's one thing that is implied. Does anybody know what that is? Yes. Okay, where they're going, and that means what?
Their speed.
No, not their speed. It's not their speed that's implied. Yes. Their distance. If we're both traveling to school, and one's going slower and one's going farther, what's implied is that our distance is the same if we are leaving from the same place. So the distance of A and the distance of B are equivalent. So in a race type situation where both people leave from the same place and go to the same place, what is implied is that the distance is the same. Okay, the next situation is when you start at the same point at different points and you travel to each other. So then what's implied is the distance that A travels plus the different distance that B travels is equal to a total distance of C. That is implied. You should be writing these diagrams. The last kind of situation is when you start at the same place and you both travel for a certain period of time. Your two distances will also equal a total distance. You should be writing the diagrams. All of these you should be on your third. So in this case, A plus B, the distance of A plus the distance of B will equal a total distance of C. Now these are implied. There's one more thing that's implied. You see something and they don't tell you this, but they'll say, you know, the airplane is traveling at 400 miles per hour and he goes for 2 hours. How far did he go? First of all, because they mentioned MPH, because they mentioned hours, that should give you a red alert that there's a formula to be used. What formula are they implying to use? Lucas. D equals, very close, but the formula's wrong. But you're right, it is the distance formula, but distance equals rate times time. Good. So that is implied. They're not going to say, hey, guess what? It's time to use the formula. Okay, in the real world, when you're walking down the street and you have to apply this kind of math, they're not going to, God's not sending you a message and saying, guess what? It's time to use the perimeter formula. It's time to use Pythagorean theorem. It's time to use the distance, rate, and time formula. You have to be thinking about that. Oh, I see we have miles per hour. I see we have time. I see we have miles. It's time to use that formula. So we can solve these in two ways. We can solve it with one variable or we can solve it with two variables. So let's go to our, you don't need to write those notes. Let's go to our scenario. So the first thing we have to do is differentiate what we're talking about. What am I comparing? Two planes take off from the same airport at the same time. One plane travels east, the other travels west at 200 miles per hour faster than the eastbound plane. Find the speed of each plane if they are 2,000 miles apart after 2 hours. So the first thing I'm going to do is draw it. Okay? Actually, before I draw it, what am I comparing? What am I comparing? Lucas. I'm sorry, Oliver. How do I differentiate what I'm talking about here? What am I calling them? Mary.
Plain east and plain west.
Yeah, we're just going to call them east and west. Exactly. And I mentioned to you, oh, I see miles per hour, I see hours, I see miles. So what formula do I have to use? So I'm going to put in rate times time equals distance. Okay, now I want you to draw the diagram. Okay? Are they starting together? Are they starting apart? What's happening here? Sabine?
Starting together, it's travel away.
Okay, so I'm going to do this, and I'm going to kind of draw. One is going slower than the other. Which one's going slower? The east. So, right, we have never eat soggy waffles, right? So my east is going to be to the right. And we know that he is going a shorter or a longer distance. So we'll call him the east. And then, so I'm going to make this one a little bit longer. We'll call him the west. Okay. Now, all together, what do we know? What do we know? Mary.
That the sea, which is how far apart they are, is 2,000 miles.
That's 2,000. Okay. Do we know how many miles west is? Do we know how many miles east is? No. We also know that it takes them 2 hours. Okay. Now, let's call this one east, this one west. Do we know their speed? No. So, I am using the A plus B equals C eventually. Okay, now, what do we know for... Okay, let's... Hold on. I'm going to pause it, and we're going to walk this out. I'm sorry I can't do this for the video. I'm pausing the record. So, we just walked it out and did an example of this, and what we noticed is that time is what? 2 hours. It's the same, so we can fill that in right away. Okay, tell me about the rate. What do we know? Okay, Daniel Yoon? Okay, and I'm not going to use X, I'm going to use R. We don't know the rate, but what do we know? We don't know the rate, but what do we know? Ethan?
The plane that's heading west is going 200 miles faster.
It's going faster, so how would I show that?
R plus 200.
Good, plus 200. Now, tell me about the distance. Do we know the distance of the east and the distance of the west? Each one individual. We know the sum of them. So we have to add our sum at the bottom. Right? And our sum is how much? 2,000. Okay? So I don't know the distance, but what do we know? Rate times time is also equal to distance. So can we call it something else? Yes.
Well, I was thinking if they're 2,000 miles apart, that means for east it would be D, and then for west you could do it E.
I could do that. Sometimes I call this distance 1 plus distance 2 equals the total. Sometimes I do that. But tell me, what are we going to use right now for the distance, Mary?
2R.
2R. It's the same thing as distance, right? Rate times time is equivalent to distance. And what will the other distance be called? Oliver? Good. And so, what do? We multiply going across, but what do we do going up and down? Add. So we are going to add this, and it equals the sum. So I have 2R plus 2 times R plus 200 equals 2,000. Now remember we said distance A plus distance B equals the total. Another way we could write it is this is distance 1 plus distance 2 equals the total. Okay, now we can simplify. 2r plus 2r plus 2,000. 400. 400 equals 2,000. That's 4r plus 400 equals 2,000. Subtract 400. 4r equals 1,600. Divide by 4, divide by 4. And r equals 400. And that is for what? East. That is for east. So this one is 400. And that makes this what? 600. So when they say, find the speed of each plane, west is 600 miles per hour. East is 400 miles per hour. Okay, are there any questions? Okay, yes. Huh? Does it ask? But that's good, Lucas. I'm glad you asked that. Because sometimes you will find something you always have to go back to. And I did go back to. And make sure you're finding. Because once you find that, you have the ability to find the distance. They might ask that. Yes.
How much do these books cost again?
Okay. We can also solve this with different variables. I'm not a fan of that. The next one I will show you how we're solving with two variables. Okay, Karen leaves for work traveling at 50 miles per hour. 15 minutes later, Mark chases after her with her briefcase traveling at 70 miles per hour. Okay, so right away I'm going to draw it. Here's Karen leaves, and boom, she gets to work. Here's work. And then Mark leaves later, and he has to catch her, right? You with me? Yeah. Okay, Karen and Mark. So tell me what is implied here. What's implied? Mary?
The same distance.
Same distance. I don't know what it is, but I know it's going to be the same. Okay, Karen leaves for work traveling at 50 miles per hour. Where do I put the 50? Where do I put 50? Under rate. Okay. 15 minutes later, Mark chases after her. So this is a distance 1 equals distance 2. Let's finish. 15 minutes later, Mark chases after her with the briefcase. It's 70. Is the time the same or different? She leaves, and then 15 minutes later, okay, so let's call them both time, but how is his time different? Yeah. It's not plus 15, minus, and it's not 15 because I'm talking about MPH. So I have to do minus, I have to convert 15 to hours. 15 out of 60 is 1/4. Now, do I know what this is? Let's call it distance 1. No, let's call them both D, right? Because they're the same. That's what's implied. So if that's the case, now what I have is 50T equals D, and 70 times T minus 1/4 equals D. Oops, no, sorry. Yeah, that's right. Equals D. And now what can we do? Yep.
You can set them to equal each other, so 50T is equal to 70 times quantity of T minus 1/4.
Yep. 70t minus 70 over 4. And then we solve. Okay? So I'm doing 70 over 4 is 17.5. So I'm going to change that to 17.5. I'm going to subtract 70t minus 70t, and we are left with negative 20t equals negative 17.5. Divide by negative 20. Divide by negative 20, and t equals 0.875. And remember, this is in of hours. If you want to convert that to minutes, I'm doing dimensional analysis. 875 hours over 1. I'm going to multiply by hours to minutes. That is 60 minutes to 1 hour. And then we end up with 60 times 0.875 is 52.5 minutes is equal to time. Okay?